Alright, this is going to be somewhat of a continuation of the previous video on domain and range. But this is going to be a little bit more advanced, and remember we are talking about Python here. So we're going to be introducing a thing called a list and float, and how to maybe round off a rational number to a few decimal places. But the function we're going to be looking at is f of x equal to x squared minus 3. And we're going to create the domain and store it in what's called a list. But before that, let's go back to composite functions in the last series of in the last video. Writing our function out first, f of x is equal to x squared minus, I believe it is 3. Now, in the previous video, we were just using 1, 2, 3, 4, and so on. Well, whatever it was, it didn't go to infinity, but up to n. We were using this as the domain. And now what we are going to want to do is do things like 0.5, 1, 1.5. So as you can see here, this is got a increment of 0.5, right, added to each one of them. We better say up to n because this is not an infinite set. So what I'm going to do is I'm going to talk about the idea, kind of a continuation of the idea that we talked about earlier, and that was the idea of composite functions. And I'm going to let this one be 0.5x, this g of x to be 0.5x. So if I plugged a number in, for example, g of 1, and plugged it into here, we'd have 0.5 times 1 is just 0.5. And then let's say g of 2, so 2 times 0.5 is 1. So if this is the domain, then you can kind of see that this function here is going to actually generate this domain. And then what you'll want to do is take these values and put them into this function here. So really what we're doing here, this is f composed of g of x, you see. So you take 1, well, anyway, we'll take 1, plug it in here, and then this gets translated or transformed, or however you want to say it, mapped to 0.5, and then so 0.5 is actually going into this function up here. So let me just rewrite this. So this is f of g of 1, and that's equal to f of, and now g of 1, remember, is 0.5. And then of course we evaluate, we plug in 0.5 squared minus 3. Alright. So as you can see here, we're gonna use this idea of the composite function. So this stuff here is your domain, right? And the whole thing, once it's evaluated, it's mapped to the range. It's mapped to the range. Alright, well, let's look at the Python code for this. Actually, I think first what we're going to look at is the output. So this is the actual output. I've defined our Python function here as g. Okay, and what you're going to see over here in the left-hand column, this is our domain, and this, of course, is our range. And we're going from 0 to 5. And of course this is just with increments of 1 like we did in the last tutorial, but I kind of spruced it up a little bit where you can actually see the function here, f of x equal to x squared minus 3. But in this one down here we got increments of 0.5. Now we weren't able to do that using the methods that we used last time. Alright, I'm going to go ahead and run our Python function here. We want to go from 0 to 5 and 0.5 increments. And there it is. So here's our function. Here's the domain, I guess I should say. And here's our function f of x equal to x squared minus 3. So you can kind of plug some numbers in and see what we get. If we plug 1 in, 1 squared minus 3 is negative 2. Now you notice, or you're going to notice here shortly, that the decimal point is going to be rounded at most to 3, and I'll show you how to do that here in just a minute. But so this is our output, and this could be very useful. Okay, I was going to mention something about a module in Python, but I think I'll hold off on that. Alright, so this is what we want to construct. This is the goal right here. So I've got the code here already typed out. I think it just saves time when I do that. I don't know if it really helps you out any or not. Here's our parameters, A, L, and S, and you know, I just picked some letters out. S kind of means step, and I don't know, I just kind of picked those off the top of my head. But this thing right here is called an array. Sorry, it's not an array. In JavaScript it's an array, but in Python we call this a list. Now of course you notice this is an empty list. This is where we're going to store our elements of our domain in. I'm starting with c is equal to -1, and that's for a good reason. Taking the difference of L, if for example if we went from 0 to 10, this would be 10 minus 0 is 10, and then of course if this is 0.5 goes into 10, well, 5 times, so that's going to end up being b is 5, and so we should end up going to or there should be 5 elements, I believe, 0 to 10. I don't know. Anyway, we are incrementing it by 1 here, of course, and what this means is, you know, we're going to plug 1 into the function, 2, 3, 4, 5, and so forth. Now this right here, okay, in the sketch on the board, this would be our y is equal to 0.5x. Let me just go back to the board. Okay, that's actually this piece here, but I don't have a plus number on the end of it. We just got this piece here. Okay, so let's see if you can figure that out, right? So S, which is the step, like if this was 0.5, we would plug 0.5 in here, and this would be X. Okay, and it depends on where we start. If we started at 0, then you just have y is equal to 0.5x, but if we start at 1, then we need to add 1 to this. This piece right here is actually the part that's going to do the rounding. This says at 3 decimal places, so we're going to round, and it won't be any more than 3 decimal places. You're going to see this thing cut off at like 1 decimal place or 2 decimal places and wonder why that is, but it shouldn't get any higher than 3 decimal places. Float, this actually becomes a string, what's called a string, and so we want to turn that number back into, or we want to turn that string back into a number, and we're going to do that by putting float here because we're going to have some decimal numbers here, and so we would say float and then y, and I'm just assigning that to be z here. And then append means, what append is, D up here is our list, and what append does, this method, it takes that and tucks it into the list. So this just doesn't, all this does is put it into the list. That's all it does, places it into the list. And of course we're going to return the list. And let's just go ahead and run. Let's run this. I call it DOM for domain, but let's just go ahead and run that. So DOM 1 to 5.5. And as you can see here, this is our domain. Printed out as I need to make a correction real quick here. I was doing an example. Oh yeah, this was 10, 0, and 0.5. Yeah, okay, so that'd be 20, not 5. I don't know what I was thinking. Um, anyway, I was thinking of one that I think I'd printed off already. But we were looking at this function and its actual output, which was the output, was the domain. That happened to be here. So this is the actual domain if we were going from 1 to 5 of 0.5. 1, 1.5, 2, 2.5. So we were storing our elements of our domain in a list. And I want to go ahead, and of course you could just hit the upward arrow key and do that example I was actually made a mistake on. That was 0 to 10, and we should have 20 elements come out. Okay. Of course, we can't get everything on the screen here, which is an issue. As you can see here, we start with 0.0, and it goes up to, scrolling over here, 10. And it turns out that there's 21 elements actually in this list. 21 elements in the list. So there was a few things new if you didn't know. The append, which actually puts it into our container here, our list, each element as we generate it. And what else would be new? I guess the float, maybe the percent sign here. If we wanted to round it at most to 4 decimal places, we'd put 0.4. Or 1 decimal place, 0.1 here. F means float. Alright, let's scroll on down and take a look at the rest of this. Of course, here's our function right here. You should be familiar with how I'm doing this in the previous video. We go ahead and define our function, f of x. Of course, our return is y here, but we have math dot power x, right? So this is x squared minus 3, but we have to use this. And now here's where it's all taken place, right here. So this is going to be our lower and our upper, and then the increment here, or the step, sometimes they're called. And of course this is the first piece, that was the top, and then printing the domain and range. And we go back now and we utilize this the DOM function, right, our domain function. And this is a nice nifty little thing right here. We have 4x in the domain. And so what it's going to do, it's going to loop through that domain as we go down through here and then print it off, and then it's going to go back and go to the next one. So it's going to automatically start with the very first element in our list. The very first element in our list, so it takes that first element in the list, stores it as x, then we plug it in here into our function f of x, which we've already defined up above. We're going to round that to 3 decimal places. This whole thing here becomes a string, so what we're going to have to do is get it back into a number, and in this particular case it's called a float because it's a rational number, and that's what the whole float thing does. And then we just print it out. We print our x out, starting at basically the first element in our domain. That's what our x is, and then of course z is that element that's in the range that corresponds with x. So it's real simple, but this can be extremely handy. There are some actual methods, or there's actually some built-in functions, but you have to import what's called NumPy. N-U-M-P-Y. You import NumPy, and I'm sure I'll be using that at some point in time. And we could actually just plug in the number 0, 10, and then put in 0.5 for the step. And that method is known as the, I think it's arrange, A-R-A-N-G, arrange, A-R-A-N-G-E maybe. Anyway, we'll utilize that, but I'm thinking maybe we should just try doing this from scratch first to kind of learn Python before we start importing modules. Even though we did import the math module, you'll find the script underneath the video. Alright, thank you.